Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to look at Redshift. So what is Redshift? Well, you probably remember from the Databases 101 section that Redshift is a way of doing business intelligence or data warehousing in the cloud. So Amazon Redshift is a fast and powerful, fully managed petabyte scale data warehouse service in the cloud. And customers can start small for just 25 cents per hour with no commitments or upfront costs, and you can scale up to petabytes or more for $1,000 per terabyte per year, less than 1/10 the cost of most other data warehousing solutions. So if you need a data warehouse, Redshift is the one to use, and certainly in terms of the AWS world. So we learnt in the Databases 101 the difference between online transaction processing versus online analytics processing. And online transaction processing is if you take a store, you could go in and look up a particular order, and you'd look it up using an order number. It's a single row of data. Whereas online analytics processing is where you're running queries against your database. And it might be that you want the net profit for EMEA and for the Pacific for a digital radio product. And this is going to pull in a huge number of records. It's going to add up the sum of all radios sold in EMEA, so Europe, Middle East, and Africa. It's going to add up the sum of radios sold in the Pacific. It's going to grab the unit cost of the radios in each region. It's going to take the sales price of each radio in each region, and then it's going to calculate the sales price minus the unit cost. And you can imagine the sort of queries that it's going to be running to do this. It's going to pull in data from a lot of different areas, and it can put a big stress on your database. And that's why it makes sense to move your production database and to have a separate data warehouse where you're running these queries on. So data warehousing databases actually use a different architecture, both from a database perspective as well as an infrastructure layer. And Amazon's data warehouse solution is called Redshift. So Redshift can be configured as follows. You can have a single node, and this is 160 gigs in size, or you can have multi-node. And a multi-node will consist of a leader node, and this basically manages the client connections and receives queries. And then you have all your compute nodes, and these store data and they perform queries and computations. And you can have up to 128 different compute nodes behind a leader node. So Redshift uses really advanced compression, and instead of going in and compressing individual rows inside a table, what it actually does is it compresses individual columns. And because the columns contain the same data, so one column might be a date, for example, or another column might be text, or it might be an integer, or it might be a Boolean value, or whatever. When you use compression based on columns, you get a lot more, it's a lot easier to compress because all the data is the same. So Amazon Redshift employs multiple compression techniques and can often achieve a significant compression relative to traditional relational database stores. So in addition, Redshift doesn't require indexes or materialized views, and so it uses less space than traditional relational database systems. And when you're loading data into an empty table, Amazon Redshift automatically samples your data and selects the most appropriate compression scheme. Redshift also comes with massive parallel processing, so it automatically distributes data and query loads across all your nodes. And Redshift makes it easy to add nodes to your data warehouse and enable you to maintain fast query performance as your data warehouse grows. So you can actually scale out with Redshift by adding more and more nodes behind your leader node. In terms of backups, Redshift comes with backups enabled by default, and they'll have a 1-day retention period. Again, just like with RDS, your maximum retention period is 35 days, and Redshift will always attempt to maintain at least 3 copies of your data. So this is the original data and a replica on the compute nodes, as well as a backup in S3. And Redshift can also asynchronously replicate your snapshots to S3 in another region for disaster recovery. Redshift, the way it's priced, it's basically on the compute node hours. So this is the total number of hours you run across all your compute nodes units for the billing period, and you're going to be billed for 1 unit per node per hour. So a 3-node data warehouse cluster running persistently for an entire month would incur 2,160 instance hours. And you're not going to be charged for leader node hours. You're only going to be charged for your compute node hours. So bear that in mind as well. And then you're also going to be charged for your backups, and you're going to be charged for your data transfer. And this is only within a VPC, not outside it. In terms of security considerations, when you're communicating with Redshift, it's always going to be encrypted in transit using SSL. It's also encrypted at rest using AES 256 encryption. And by default, Redshift takes care of the key management. So you don't have to worry about managing keys with Redshift, but you can manage your own keys through a hardware security module, also using the AWS key management service. And we do cover off Cloud HSM as well as AWS KMS in an awful lot of detail in the Certified Security Specialty course. In terms of availability, Redshift is currently only available in one availability zone, so you cannot have Redshift with multi-AZ turned on just yet. Who knows if that will change. You can restore snapshots to a new availability zone in the event of an outage. And then just onto my exam tips, just remember that Redshift is used for business intelligence. It's only available in one AZ. And in terms of backups, it's enabled by default with a 1-day retention period, and your maximum retention period is 35 days. And then Redshift will always attempt to maintain at least 3 copies of your data, the original and the replica on the compute nodes, as well as a backup in Amazon S3. And Redshift can also asynchronously replicate your snapshots to S3 in another region for disaster recovery. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we're going to cover off Amazon's Aurora.